Hello everyone, welcome back to the channel. Ever had a Kubernetes cluster struggling to scale, or maybe you are managing uh, nodes provisioning through manual options in Azure Kubernetes Service? Well, you are in the right place because today we are going to discuss about using AKS Node Auto-Provisioner service. This is an incredible powerful tool that can make your cluster automatically add nodes and deprovision nodes based on the workloads demand and uh, use it for your workloads optimally. So let's get into the details and we'll see how we can use this service through a demo as well. So what is AKS Node Auto-Provisioner? It is basically a service that provision your AKS cluster nodes based on the demand and the requirement of the workloads. So for example, let's assume that you have a workload which need higher memory. So when you deploy that workload into the cluster, AKS Node Auto-Provisioner will go through how much of resource that are needed for this workload, and based on that, it optimally suit which kind of a node that is suitable for the workload. In AKS, we have different kind of um, storage sizes and storage types. So based on the workload need, it will figure out which type of SKU family is best for the workload. And another thing you need to know about AKS Auto Node Provisioner is it is based on the open source tool called Carpenter. So therefore, this architecture is similar to the Carpenter architecture. So you can see in this diagram, you have existing capacity and you have the pending workloads, right? Then what happen is when there are unscheduled imports, Carpenter or in the case the node auto provisioner will go through the unscheduled pods and figure out what type of nodes need to be provisioned. Then it's like a just-in-time capacity, on-demand capacity. Then the node auto provisioner will go and provision the required node and um, schedule the unscheduled pods into that specific nodes. So therefore, when it comes to the overall capacity, you can see um, AKS Node Auto Provisioner will make sure that proper capacity allocations are allocated to that specific nodes. So therefore, you are not going to over provision the nodes or under provision the nodes. So if there are smaller uh, pods that not need much resources, then um, node auto provisioner will schedule them in the proper node pool that is required, right? Then when we talk about the key benefits, so it is fast and dynamic scaling. So because uh, you can easily dynamically scale your workloads and use node auto provisioner to schedule appropriate uh, pods into the proper node pool, and it is on demand, right? Then optimize resource utilization. So therefore, you are not underutilized resources, you are not provision resource underutilized or overutilize your resource. Right? So simplified node management. So you don't have to put a lot of effort managing the nodes as well as auto scaling because the node auto provisioner will take care of. And on demand and on spot instances will come to the place because based on the pod's requirement, we are on demand provision the workloads for the uh, on demand. We are provisioning the nodes to required for the workloads. There are a few limitations when it comes to the AKS Node Auto-Provisioner. This is only support at the moment with Azure CNI overlay and which is powered by Cilium. And you cannot use cluster autoscaler uh, with Node Auto-Provisioner. And there are some features are not supported at the moment, such as Windows Node Pools, Service Principals, and IPv6 clusters as well. Okay, now we have some idea about how AKS cluster node auto provisioner works. So we'll go and see how we can provision it, and we'll deploy sample application, and we'll observe how the node auto provisioner will work. Okay, now we are back to the demo of how to provision AKS node auto provisioner. So first we will see how we can provision the AKS cluster auto scale node provisioner, right? So in here I have few scripts. So for example, if I take this commands.accli, you can find um, the commands that are required for provisioning the cluster. So I will provide this file and the required uh, YAML files that need to for this demo. Okay. So first what we'll do is we will include few variables so that we can use them for our provisioning the cluster. So here you can see I have few variables, which is my resource group name, location, and the cluster name. Then I will do is I will log in to the subscription. So I will use my subscription. So this will provide me the available subscription for my tenant. Then I will select the subscription. Then now I have the subscription selected. Next, what we need to do is we need to install the extension, AKS preview extension, because this is a preview feature. So you have to make sure that this AKS preview extension is installed into the ACCLI. If you already have it, you don't want to add it to your CLI, but this is the first time you are trying AKS preview feature, then you should add it. Then we need to update if we already have the AKS extension, AKS preview extension for Azure CLI, then it is good to update to the latest version because this feature may be included in the latest version of the AKS preview extension. Now you can see it is already installed. Then next we need to do is we need to register the feature uh, for this node auto provisioner preview feature. You can use this AC feature register command to register the feature. In my case, I already have it registered. So if you don't, then the state will be shown as registering. Right? Then if you want to see the feature is registered, then you can use AC feature show command to view the uh, status of the feature. So under the state, if it is marked as registered, that means you can use it for uh, your uh, testing, right? Then after that, if it is marked as registered, then you have to make sure that this provider is registered. Microsoft Container Service provider with provider is registered with the newest feature. Okay. Then now we have all the prerequisites that need for provisioning AKS Node Auto-Provisioner. Now what I'll do is I will go and create a new resource group for this demo. So now you can see I use AC group create and give a resource group name and the location. Then the resource group is provisioning. After that, we need to use AC AKS create command, right? So this is the command that we are going to use, right? So, but here we need to make sure that we are using node auto provisioner mode parameter as auto, then the network plugin parameter as Azure, then the network plugin mode as overlay, and the network data plane as Cilium. Because as I mentioned in the previously, this is supporting only in Azure overlay network, which is using Cilium and used by Cilium uh, at the moment. So we need to select those configuration. So now I will go and provision the cluster, right? Then this will take some time to provision the cluster. After its provision, will come back. Now we can see that our cluster is provisioned successfully. So now we can use this cluster to see how the node auto provision works. So we'll go and see whether the cluster is provisioned. So if I open my browser window, you can see the AKS Node Auto-Provisioner cluster is provisioned successfully. So here you can see the cluster is up and running. And if you go to the first, what I'll do is I will get connected. So I will copy the credential command to download the credentials. So then I will paste it here. I will run that, right. So what I can do is I can run get nodes, right. Then you can see this is the nodes which are already provisioned to your cluster. So that you can see them in the node pools as well. So you can see this is a default node pool that is going to use for provisioning the uh, the workloads, system workloads that need to run the cluster. Okay. Now mm, before we go into uh, try out the AKS node auto provisioner, we need we need to apply a node pool resource, which is a resource from Carpenter. So to specify which resource, which nodes, and the node configurations that we need for our node auto provision. So first, we will take a look at that YAML file, right? So in this YAML file, you can see the API type. This is this is using Carpenter in the background. So this is the Carpenter API it is using. Then the kind is node pool. So it's a type of node pool we are going to provision. Then under the disruption, we can specify how you should uh, um, deprovision resources uh, when they need. So there's a two parameters you can provide here when underutilized, and another parameter is um, when you want to remove them when this is empty. That means if the node is empty, only you are going to deprovision. The other parameter is you can specify as is underutilized. So that means if it is underutilized, then you will provision, deprovision. Right. Then expire times, you can specify how long you need to wait. So I will put never. Then under the templates, you can put different type of specs, right? So these specs are actually mentioned in the documentation. In here, you can see the my configuration that I use for my node pool, right? So here you can see the requirement. Here I'm specifying my operating system architecture should be AMD64, then OS should be Linux, and the capacity I want type is on demand, and SQ family I'm going to use is D series, right? So you can put multiple SQ categories as well. So then this pool will provision those SQs based on uh, the workload that are needed, right? So what I'll do is I will go and deploy this, apply this resource. So k apply dash f node pool auto provision YAML, right? Okay. So now it is applied, so you can get node pool carpenter, right? Then you can see the default uh, one that is I used for default as the name as default because I name it as default. So that is the uh, node pool I use. Okay. Then what we'll do is to test this actually in happen action. So what I can do is I can provision a workload, right, that need specific resource required, right? Before that, what I can do is I can run this command, right? Ibctl get events, right? In the field selector, I'm specifying as carpenter, and I will watch the events in Kubernetes. So we can see the carpenter will work when the resources are provisioned, right? So next what we'll do is I have a deployment here. So in this sample deployment, you can see I have specific memory requirements, right? Then I have memory limits and requirements that are needed for this workload. For example, we'll reduce this for 5 GB and we'll put it as 2 GB. So, and there's a CPU requirement as well with 2 vCPUs, right? So first we will go and provision this. Provision this. Yeah. So I'm going to do kubectl apply dash f deployment.yaml, right? Okay. Now you can see immediately you can see there's events coming right from the carpenter. So you can see it is nominated right for this specific pod, right? Then it is specifying this pod should be claimed into this specific node claim called default 7x RLZ, right? So if you go to the serial get nodes, you will see still it is not same, but if you in sometimes you will see there will be a node pool is provisioning as you can see here, right? So that is you can see this node pool is equal to the node claim name, right? Default is 7XR LZ, right? So you can see the node is provisioning. So if you take the port states, right? So you can see all of these ports are running, right? Running state, and you see the nodes which are running it, right? So you can see these ports are running in specific node, right? So if you describe the node, if you describe the node, I think you can see the cannot see the node class. Then we need to get the labels. So what we'll do is I will get nodes, right? Then I will select AKS default, right? Then I will put show labels, right? Then you can see that SQ family, right, is D, right? So you can see here Kubernetes.io instance type standard D8 V1 ls underscore V1. This is a node, the SQ family that is provisioned for this node because um, those three nodes required can be provisioned into the this specific node. That's why it's provisioned one node. Okay, now let's increase the capacity of this YAML file, our deployment, sample deployment, right? So what I'll do is I will go ahead increase the capacity like 15 GB and I will put like 10 GB, right? So that means now the port capacity increased to 15 GB, 10 GB request and limit is 15 GB, and you need to provision 3 ports with this specific resource requirement, right? So we'll observe what will happen, right? So I'm going to save it and I'm going to apply it, right? Okay, now you can see there will be a message here, right? Now you can see it is nominated, right? And the new deployment, and now it's saying that this should be go to a different node pool now, because the existing node we doesn't have enough capacity to uh, provision these pods, so therefore uh, it has to use a different. So what I do is take pods. So you can see still pending the new ones because we have to wait until the uh, new ones are provisioned, right? So you can see it's still in pending state. If you take AKS nodes, you can see the nodes are provisioning. So now you can see the pods are terminating and it is going to schedule it to another node. But you can see sometimes it is saying that you cannot provision it. So we'll wait from you some time until this is provisioned. Okay, now you can see the container is creating, right? And you can see there's additional nodes are provisioning for that specific workloads, right? And you can see the output, the events as well. So you can see uh, pods are scheduled to that specific nodes. Okay, now you can see one of the pod is running, the new pod. So if you take this pod, right? If you take this pod and click pods, then YAML, resources, memory, right? So you can see this is a pod that use higher memory, right? So now it is provision, one of them are provision. So we can see others are also provisioned. Now the third one is also provisioning properly. So here you can see the events related to carpenter. So you can see evicted. Some pods are evicted because those are not needed. And now you can see all the pods are running properly. And also you can see there are additional 2 nodes are provisioned, right, for this workload. So we can see that as well. So for example, if you got pods right out wide, right. So you can see 2 pods are provisioned into one node, and there's uh, the third pod is provisioned to a different node. So it is mix and match the nodes that need the resources properly. Right? Okay, so that's how the node auto provisioner basically works, right? So you can see that based on the workloads, demand and capacity, it is going to select the appropriate node that is suitable for the workload. So this is very helpful if you want to dynamically scale your workloads and capacity based on the workloads, right? So when you can automate this process as well. Okay, next we'll see the conclusion and what we can take out of this uh, feature in AKS. In conclusion, we can identify that Azure AKS Node Autoscaler feature is very powerful. So therefore, Azure AKS Node Auto-Provisioner is working with Carpenter, and therefore we can offer rapid scaling and optimization of resources that you are using for your workload. And it also simplifies the management of node pools, because we don't need to specify which type of nodes or pools that we need to provision. Carpenter and Node Auto Provisioner will take care of that. And in the cost price also, it is cost efficient because it support spot instances as well. So you can choose between spot instances and on demand. So if you're using spot instances, you can cost optimize as well. So in general, this is excellent solution for your Azure Kubernetes service. And with this dynamic and if you have a dynamic and unpredictable workload in your organization or your application, then Azure Node Auto Provisioner will be a ideal solution, right? So yeah, that's all for this session. So we have talked about what is Azure Kubernetes Node Auto Provision, and we saw a demo, and we saw its features and advantages. So yeah, so that's the end of this. So thank you very much for listening, and if you are very interested on Azure Kubernetes service or Azure in general and DevOps in general, so please subscribe to channel, and please let me know which technologies or which features do you like to try, and I will try to demo those in upcoming videos. So thank you very much, and we'll see you in another uh, video like this. Have a good day.